Hello, my name is Carl. Welcome to my workshop and welcome to my YouTube channel. Now, I've had an excellent response to my last video about the gearbox on the milling machine. So this is going to be Harrison Mill Resto 13 and we're going to carry on with the gearbox. It's absolutely pouring with rain outside. You might be able to hear it, I'm not sure. Harry had to go to school this morning with his Wellingtons on. I've just returned from taking him there. So anyway, it's nice and warm and dry in the workshop. We have a steaming hot cup of tea, so let's crack on and we'll see what we can achieve on the gearbox today. Ooh, Earl Grey. So here we are back on with the gearbox, as I said just now in the introduction. So here's a view that's getting strikingly familiar to us now. Now, as I said in the last film, we have to get this bottom shaft out, and in order to do that we have to make it concentric by some means to get this bearing here to restart in the bore, this bore that I'm pointing at, and then we can drift the whole thing out. And I talked about making some tools to do that. Now, there's a few of you have commented that yeah, you know, don't be frightened to hammer the bearings or to tap them. You know, I've done that many times in the past. I've used sockets to get bearings in and out. I've pulled them in and out with G-clamps and this type of thing, and I'm not frightened to tap them. But obviously I'm trying to avoid that if I possibly can. And yes, I know that once I've got the new bearings on and all the shafts are back in, I'm going to have to kind of, you know, fettle them around a little bit by tapping them using tubes and things like that to get the shafts in exactly the right position that they need to be in. But I'm trying to avoid it if I can. Now, what I want to do today, because I had a conversation, a WhatsApp video call with my brother, whose channel is Retro Mechanica. He services and restores BSA motorcycles. He's got a great workshop and definitely worth a look if you're interested in that type of thing, or just in engineering in general. But anyway, the gist of our conversation was we were talking about getting this intermediate shaft out. The problem being that it's got this integral gear, or pinion rather, that's machined onto the shaft, and you can't drive it out to the right. So it has a bearing at this end, obviously, in this tunnel housing, and there's a spacer in there which you can just about see. Let me see if I can get the light in a bit more. So you can see there's the spacer in between that final cluster and the bearing. Now, in the end of this shaft, and I'll just show you that now, there is a 3/8, apologies for the handheld shakiness, but it's the best way to show you. There is a 3/8 by 16 UNC thread tapped into the end of that shaft, and it's the only one that has a thread in the end of it. So what I think I can do, and this is after having some discussions with my brother, it dawned on me that obviously I need to pull this shaft out to the left because of where this gear is. It's not going to go to the right. And my issue was, well, the whole bearing's going to come out of the housing and then it won't pass through the gear cluster. However, I need to find a way to lock this gear cluster in position, and then the shaft would pull out of the bearing because the bearing wouldn't be able to move. So what we can do is we can actually move the top cluster of gears there on the spindle, or the output shaft if you like, as far over as it will go, and that then means that the large gear here of the top cluster is hard up against this the left-hand side cluster on the intermediate shaft. So if we can somehow lock that in position, then it will lock the whole cluster on the intermediate shaft, and then we can pull the shaft out to the left, and that will pull the journal out of the bearing at this end, and then the whole shaft will simply slide out of the cluster on its spline, and then we'll be able to extract it from the left-hand end there. So what I propose to do to to lock this gear, this top gear in position, is to just knock up a small jack, like a machinist jack, that can sit against this face here. Let's just get the light in a bit better so you can see what I'm talking about. There it is. So that the face of the housing there for the tapered roller bearings is where the jack will seat against, and then we'll put it against that portion of the gear there, and that should hold that gear in that position, lock it in position enough for us to be able to pull the shaft out of the bearing at this end. I'll probably need to support those clusters with tie wraps around the top cluster so they don't fall as the shaft comes out. So what we'll do is I'll try and get a jack put together, and I'll bring you back when I've got something that I think can do the job that we've just talked about. I've just jumped over onto the lathe. What I want to do is just face the end of this nut here, bolt rather, which is going to form part of the jack that I'm putting together for helping me to pull this shaft out. Right, so I'm happy with that. That's nice and smooth now. Okay, we'll get over back to the milling machine. Okay, so back from the lathe, here's what I'm going to try to use to lock everything in place. So I've faced the end of that bolt so it's smooth and it'll sit flat against the back of the gear. And then this is just basically a connecting piece from my clamping kit. It's just a threaded hex bush M10, so that can sit against the bearing housing there, and then that'll the bolt head will sit against the gear, and that will lock. I can then thread it out and lock it in position. Hopefully I'll be able to get the spanner in there to do it. I've got my two favourite 17mm spanners here. This one I've had since I was an apprentice when I was 16 years old, and this is another favourite one of mine just because it's so versatile. But it's amazing, isn't it, the little bits and pieces of tools that you get attached to over the years. Right, I'll bring you back when I'm either putting that in there or I've got it in position. Right, so that is where it's going. If you can see that, I think you probably can. I think it's safe to say that I have tried to get the camera in a position where I can tighten this up and you'll be able to see it, but I have signally failed to do so. So I'm going to show you where this is going. I'll get you out of the way, no offense, and then I will get it tightened up, and then I'll show you it afterwards. Well, you know, I've decided what I'm going to do is let you have a good laugh at me trying to struggle to get this in. So I don't know if you can actually see what I'm doing, but I've got the spanner on the coupling end. Try and get this one onto the end that's on the gear. Right, that's gone solid. So that's now effectively locked to that in position. I'll bring you in and show you what I'm talking about. Just leave the camera rolling. It's all live, folks. Right. Let me try and show you that first. There you can see. There's the jack in position. Just sorry for kicking the camera. You can see the bolt head is up against the gear, and the coupling portion is up against the bearing housing there. It's on the wonk slightly because that's not flat, that end where the casting is, but it'll do the job. So this is now completely solid and cannot move, which means that is as well. So we can now pull or extract the shaft out from the left hand end You can just about see where my hand is there. What that means is we're going to have to go back to the lathe, because I'll show you why. Give me 2 seconds, I'll just put these spanners down. Right. We are going to use the puller tool that I made for the bushes to extract that shaft. But as I said to you, there's a 3/8 by 16 UNC thread in the end of it. So this one here is too small for that. That was the one that I made for the bearing bushes. So what we'll have to do is get another piece of M12 threaded rod, get it up in the lathe, machine the end down for about 10mm, put a 3/8 by 16 UNC thread on it, and then we can use this tool to pull out that shaft. So that's what we'll do now. We'll hop over to the lathe. Hopping being a metaphor, obviously, for moving quickly. I'm not actually going to move on one leg. Back on the lathe, I've got a piece of M12 threaded rod in there. I faced the end of it, more or less, and we want to get this down to 0.375 for our 3/8 by 16 UNC thread. Now the 3/8 is 9.5, so the core diameter of an M12 is about 9.85. So we need to take about 2.5mm off this to get down to the size that we want. So I'm just going to touch off on the threads, and then we'll set the DRO to 0. I'm going to do this in metric. That's a touch off there. So we'll go to metric. 2.5mm. I'll go 1.5 first, I think. Okay, let's take 1.5 off and then we'll have a measure. See where that's taken us to. .76. So let's take another 0.2. Okay, here we go. .5 on the nose. If you don't believe me. Well, alright, it's moved. Yeah, 9.5. I'm happy with that. Okay, so we've got this down to 0.375, as I said. We've got the 3/8 by 16 die. Put some rocal on there. We'll get this backed up by the chuck in the tailstock. We'll get ourselves a thread on there. Machine's off and is isolated. So let's get this going. Oh, it's turning in the chuck, I think. Yeah, I know I should be using a collet chuck really, but you know, for what it is, I think we'll get away with it. Right, I think we've got that started now. Yeah, we have. I think I'm going to do this in the vise. I'll turn you on. So we're over on the vise now, and we are cutting our 3/8 by 16 UNC thread. Which I think is now complete. Yes, it is. Just making sure we've got the last vestige of that. Yep, we do. Okay, so I'll clean that up and then we'll fix it to the puller. Right, so you've just seen me make that 3/8 by 16th 16 rather UNC thread on the end of that M12 threaded rod. So let's see where we're at now. Apologies in advance for the shakiness, I'm handheld again. So we've got that M12 with the 3/8 16 UNC on the end of it threaded into the end of the intermediate shaft, the middle shaft. And we've got the puller in position with a nut on it already. Good job I had enough threads there. I'd already done some machining on the other end of that for another purpose, so good job I had enough. Inside the gearbox, we've got some tie wraps securing, or supporting rather, the two clusters that are going to remain in place. We have the pre-positioned jack, as you've already seen me do. Let's get some light in there so you can see it. We've got the jack in place, which is basically jamming the top set of clusters in position to restrain the bottom or the intermediate two, so we can pull this bearing out of here. So I'll get you on the tripod now. I'll probably be moving you around on the tripod so you can see what's going on, so apologies for bumping the camera and just generally making you feel seasick. So we're back over at the lathe. I had to cut a piece of nominal bore hydraulic pipe, which is the same stuff that I used to make the puller out of, you'll remember when I made that. So I need to make a bit of an extension for the puller because I think I'm going to want to pull that shaft out, as you just saw me messing around with it. I'm going to want to pull it out, I think, rather than trying to do it by hand. It's going to be the easiest way to do it. So let's, as I say, I've cut a piece of this on the small bandsaw, the porter band if you like, and I'll just face these ends up now to square them up. Bit more. Just hand feeding it. Yep, that'll do as I think, for that end anyway. Right, let's get the other end done. Right, here we go. Bring the machine in a bit, bring the saddle in a bit closer. Lock it off. Right, let's see where we're at with that. Yep, that's pretty good. I'm happy with that. Give it a quick deburr. Right, that should do us. Let's get back over to the mill and see what this can give us. Right, I've got you in a slightly different position this time, and I hope you've got some sort of an overview. You can't really see me very well. Just take my glasses off. Right, that's probably a good thing. So I've got the extension piece that we've just made in the lathe for the puller. So let's carry on and let's pull this shaft all the way out. Right, that's gone solid. So that's one cluster off, so that means we're in a good place. I'm going to stop pulling, take the tension off, and let's see what's going on with this shaft. I may need to bring you in closer so you've got a view. That's that one off. Ah, this has got jammed. Okay. I'll switch the camera off and I'll have a look in there, see what's going on, and bring you back and show you what's relevant. Right, so here is what is relevant. We have the shaft out. It was literally just holding on by the skin of its teeth on the end of this spline here. There's the journal that we pulled out of the opposite end of the right hand side. There's the bearing from the left hand side. So that has worked a treat. I'll just show you inside so you can see the gears, how they've ended up. So, okay, so there's the clusters, and they've more or less stayed in position due to the tie wraps. Obviously the bearings come out at this end, as we'd hoped, from that bore, and then the other bearing is still in situ, still extant in the bore. And what we'll do is we will take the puller that we've modified, or that we made an extension for, and we'll do another modification of that, or a very basic modification to get that bearing out. Before we do that, obviously we'll have to take out those clusters, which I'll do in a minute. But I think I've earned myself a cup of tea, and I'm going to go and have one now. So I'll bring you back when I'm refreshed. Okay, so I'm back. Not only did I have a cup of tea, but lunch was declared, and I've also made my family a very tasty bolognese, even if I do say so myself, for dinner this evening. So it just goes to show you that we engineers can do everything. We can make parts on a lathe, we can take a gearbox to pieces, and we can make delicious food as well. We can cook. So yeah, there you go, we can do everything. Right. I tell you what, let's turn that round. Here's the shaft that we took out, the intermediate shaft. Let's get this threaded rod out of the end of it. That was easy. Now we've got that out, let's get this bearing off. So we'll put the spline down in the swing arms. Now I've got these aluminium vice jaws that are made for it. They're not, they're not posh ones like John of John's Workshops, but they'll do the job. So let's go and get that off there. It's quite oily, but never mind. Let's get the bearing puller on it. Right, repaired over to the other side of the workshop. Now, these bearing pullers are great. I got them, they're Sealy, and they've really been excellent for me in everything I've done on this machine so far. I have to say they've definitely earned their money because they weren't very expensive. Now, I need a 9/16 for the end of there. Let's get that. Always clean the tools before you put them away. Right, where's my 9/16? There it is. Here it is. Right, let's pull this bearing off. Here we go. Can you see? Yes, you can. Off it comes. It's off. I do like a nice journal, and that certainly is one. Right. Oh, don't drop it on the floor, even if we are going to replace it. Yeah. That one doesn't feel too bad, but the one I took out, be better if I was on camera. If it was the one I took out the other day, that's a bit wibbly wobbly, that one. That was off the end of the drive shaft. Yeah, so there you go. So what we'll do now is we'll reposition you, and we'll get the clusters out of the gearbox. Let's do that. Okay, so I'm going to get the makeshift jack out, which you can just about see there. So using my two favourite 17mm spanners, I'll get that jack out. That will enable me to then move the top cluster to the left, giving us a bit more clearance to remove the intermediate clusters. Right, so we'll use a long spanner for holding the jack, holding the body of the jack. Oh, there we are. It's already loose. Right, it's moved slightly. Okay, we'll have to wind that in a bit. Can I get my hand in there to do it? Let's see. Yes, I think oh well, it's gone in the bottom of the gearbox, but it doesn't matter. We can retrieve that in a minute. Let's get those clusters out first. So, we'll move that way. Slide it off the tie wrap, actually, no need to cut it. Right, here's the first one coming out. So this is a bit of a sort of a noteworthy moment, really, I guess. The fact that we are taking the first shaft out of the gearbox and the first cluster of gears. So you can see how this is constructed. It's basically a boss on this gear, and then a gear ring for the second gear in the cluster, which is scotch keyed with grub screws to the boss on the first gear. And you can see there, look, it says L6/2. This is because we're dealing with lathe gears here. Harrison L6. And see those markings on that gear? Can you see them? Now I don't know what's caused that. I don't know. I don't think that's necessarily machining marks, although it could be. I'm just wondering if that's been chafing against the top cluster, the larger gear on the top cluster there at some point in its life. Well, there you go. That's the first cluster out. So let's get the second one out now. Put this one in the plastic box. The ubiquitous plastic box, which is just out of sight. Right, so that spacer there, this one that you can see down here, I just need to be careful of that because it might do the ubiquitous thing and fall into the bottom of the gearbox. Let's see if I can grab hold of it. I've got it. Right, there's a heck of a nick on that. Can you see that? Look. You can't see it. Can you see that there? I wonder what's caused that. See it? There's a big dent in it. Yeah, so that's not been... that's a raised edge, so that's been up against something. I wonder if that was done when it was fitted. Because I don't think... There's another one there, look. A scratch. Yeah, there's two of them. So, let's just have a look at this actually, while we're here. I'm going to just wipe my hands and focus in on that, because I've got a bit of a theory about what caused that. I'm just wondering if that's been done when this has been assembled. Zoom in on it a bit, let's get it to focus. Come on, you can do it. There we go. Right, there's one there, look. There's one there. And I just wonder if that somehow happened when it's been put together. No, it can't have done, can it? Because, let's have a look at the shaft. Zoom back out. A bit of an interlude. It could have done because... No, it doesn't go anywhere near the splines, look. It fits on the journal there. I thought perhaps the splines had done that, but I don't think they have. Yep, so that's a mystery anyway that we'll probably never know what caused that, but there you go. Put that back in the box. Let's carry on. We'll take the other cluster out now and have a look at that. That should come out nice and easy. Oh, it's heavy. Right, so there we are, the 21 tooth gear L621, and again we can see the same type of construction, a big boss, and then the other gears are essentially gear rings, or this gear is a gear ring which is scotch keyed onto the boss that has these two integral gears on it. So yeah, there's the spline, you can see that. Very pleased with that. That went really well, that operation, to get those out and to get that shaft out. Okay, so put that in the box for safekeeping. Right, what we're going to do now then. I just want to show you something actually in here. I'm going to just reposition you, so I'll just wiping my hands. I'll just turn you off for a minute. I'll bring you back. Right, so before we go and take out the right hand side bearing from the intermediate shaft, I just want to show you something here. Now, this cluster of gears on the drive shaft, or the spindle, should be able to stay put when you move it with this. In other words, there should be a detent on it. And it just seems to slide quite freely backwards and forwards and have no real kind of restriction to its movement, or no positive positioning. And I think that might have something to do with why the gears have possibly been clashing and causing marks and wear marks on the other clusters. So, according to the drawing, let me just get something to point with. According to the drawing, there should be a detent mechanism in there, and that's composed of, let me show you. So this grub screw here is bearing against a spring inside here, in theory. I haven't checked inside there to see if it is yet, but how it should be assembled is the grub screw should be bearing against a spring, and then there should be a ball on the other side of the spring, and that should engage in some scallops in the shaft, or pockets in the shaft, and give us our detent action. But it's not doing that, or it doesn't appear to be. Now that grub screw is loose. I can turn it with my fingers. So I'm going to have a go at tightening that up. I'll try and zoom you out a little bit so you can see, get the light in a bit better. That's more like it, isn't it? Right. How's that? You can just see a little bit of the light there. That's not too bad. We'll leave you in that position. Let's get, I reckon that's probably 5:30 seconds. Quarter UNC grub screw. Let's have a look and see if we can tighten that up. Let's get the ratchet. Right, just check I've got the right size. Yes, okay, yeah, that's definitely turning. I can feel it going up against spring pressure. Give it a little. Right, that's gone solid now, so that's actually locked that shaft in position now, so let's slacken it off a bit. Yeah, that's definitely having a detent action now, so let's just give that another little nip. The other way. Come on, Carl. Nip it up fully. Let's back it off a quarter of a turn, or an eighth of a turn, something like that. I get the handle on it actually and see, because that will tell us, won't it, if we put the handle on. Right, that's solid there. Another eighth of a turn. Still. Oh no, that's more like it. Now that. Yeah, I can feel that's definitely detenting. It's probably only meant to do that. Yeah, can you see the sort of how it just springs back like that? You can hear it clicking as well, can't you? Right, so that's something that we can have a look at when we take the spindle out. Anyway, so now we'll get set up for removing this bearing. This one here. Right, so we have got, I've cut another piece of M12 threaded rod that's now long enough to go through. Yeah, I've got a big washer and a nut on the other end inside the gearbox on the bearing itself. So we can assemble the puller. Let's make sure that's concentric. It's done me proud as this puller. That's pretty good, yeah. Okay. I got the nut on actually, and then we'll line everything up. I'm going to come in front of you and put my hand inside the gearbox. You can still see. Right, let's get that on there. Right, that's nice. Let's get it a bit more central on the bearing. That's good. Okay, right. So, we'll get a 19mm, can't even speak, 19mm socket on this end and see how we get on. My favourite 19mm and my favourite ratchet handle. Here we are. Can you still see what's going on? Yes, you can. Okay, right. Helps if you turn it the right way. Right, okay, I'm going to have to lock this end. Yep, here comes the bearing. Right, I think I'm going to have to put, yeah, I should have done that anyway, shouldn't I? Right, I'll bring you back. I just need to double nut the end here. Just to get, we'll set it back up again. I've locked two nuts together on this end just to prevent them from pulling out. Get the 19mm spanner on. There's going to come a point, obviously, when I can't do this. Probably have to swap them around. Right, it's definitely pulling the bearing out. Right, we'll put the socket on this end now to lock that, and we'll turn the spanner at this end. Now this is the longest housing on this machine, on this gearbox. It's quite a tunnel, but we're almost there, I think. Let's have a look. Yeah, we're nearly there. Let's just see if we can centralise it a bit. That's it, we'll keep going, we're almost there. Maybe this isn't very particularly exciting watching, but this is me actually doing it. You're seeing the process. Let's have a look. Where are we? Oh, almost there. Right, keep going. Keep going, that's the thing. We are almost there. Probably half an inch to go. If that. Right, okay. Let's do this. Put the socket on that end. Put the spanner on this end. We're moving it. Any minute now, it's going to go pop. Right, that's the socket fully in. Put an extension on this. It helps if you go in the drawer that says extensions. There we go. We're almost there. Keep saying that. Hey, there you go, look at that. Right. Let's have a look at this bearing. So we'll undo the nut. Thank goodness for M12 threaded rod, is all I can say, really. There it is. Ta-da. Right, you must be getting really fed up with this view now, so obviously we've taken this bearing out. I measured this bore, and with the exception of this bearing here, the others are all the same size, apart from obviously the taper roller bearings in that end. So that come out, I measured it with snap gauge and a micrometer, and I got that to 1.874 inches. So that's the size, slightly smaller, maybe 1.87 is the size of the sleeve that we need to make to push through to centralize the lower shaft. Now, looking at this, I've just been thinking I might give it a go without any kind of alignment tool, just to see if I can get this end started, and if I can possibly drive it out without any sort of alignment tool. Not massively keen on the idea because it's leaving things to chance, and I don't like leaving things to chance. I like everything to be controlled, and to do things in a controlled fashion, and using engineering principles and all that other good stuff. But let's give it a go anyway and see if we can get that bearing started in there concentrically, and if we can, then it's all to the good. So we'll give it a shot. Right, well, it's good news. Let me show you. I'll zoom you in. I've managed to get the bearing started in the right hand end without using any fabricated or machined bushes, and I'll show you how I've done it. Just as fortune would have it, the old bronze nut, remember when we made a new one of those, was perfect to use as an alignment bush. And I was maybe accused of being a little bit risk averse in the last film, and yeah, possibly right, but I didn't have to make anything at all. That bronze nut has worked perfectly as an alignment bush, so I'm now going to drive the bearing all the way through the right hand side and out, so you should be able to see that reasonably well from there. So let's carry on. If it starts doing anything stupid, I'll stop, obviously, but yeah, we're moving it. I'll put you at the other end, at the right hand end, and you'll be able to see it coming out. Sorry about these bizarre camera shifts, but as I've said before, I'm actually doing it. This is real time. You'll see me dismantle this, and you're seeing my thought processes and my mistakes. It's warts and all, so you know, you're seeing the whole process, which I think is a good thing. You know, I'm trying to be honest here. I need a slightly longer drift now, or maybe I just need to take that bush out of the way. Right, here we go. It's gonna go sing. Come on, can't be long now. It's out. Right, there we are. So we can get that bearing off now. No harm's been done to the journal. We can pull that off. Can you see that? Yes, you can. Right. We'll pull that off. That's where the spring clip was, do you remember? And then we've made some progress today, haven't we? Yes. So we'll get that bearing off, and we'll get the components, the cluster and the slinger off the shaft. I am very happy that that worked nicely. Right. I'll stop you there, and I will get the puller. Right, so what I did was I instead of pulling it in situ, which is a bit silly really, I took the components off the shaft, the slinger and the two gear clusters, and I've now got it in the vise in the soft jaws, and I'm going to pull it on here. So once I've done this pulling operation, I will show you the components that came off. So I just need my 9/16 again. Here we go. Right, so let's get this off. Is it going to come? No, because that's gone wonky. Come on now. You can do it. Here we go. It's coming. Right, there we are. That's off. There she is, the drive pulley bearing. Right, so I'll show you these components that came off. And before I do that, actually, I just want to show you something else. I had a bit of trouble getting the slinger off. Here's the shaft, so That's my teacup. You've got the journal, obviously the drive end where the pulley goes, the machine shoulder, we've got the groove where the spring clip goes, the E-clip, then the journal at the other end. Now, can you see just about there, there's like a round mark, a witness mark. That's where the grub screw was for the slinger, and I had to file that very gently with a small needle file just to get the slinger and the gear clusters to slide over that, because they were getting jammed in as the splines went over. So that sorted that out. Just a bit of a work with a fine file. Put that in the box. Right, here is the small cluster of the two. So that's that off. And then let's give it a bit of a wipe actually with a rag. Here is the larger one of the two, the 21 tooth, this end. So you can see the construction again. You've got a big boss machined, or rather the way this gear is manufactured, it's got a boss machined on it. And then at this end, this is a ring gear, which is then pushed over the boss and then scotch keyed in place. Probably shrunk on that boss as well and then scotch keyed in place, just to make sure it doesn't go anywhere. So there you go. And finally, the wondrous slinger. There he is. So that came off as well. Right. Yes, so I think at this point I'm going to call it a day, because the video is probably already incredibly long and that'll just bore you to death. So we'll call it, I think. So we're handheld again and just having a look at that grub screw, or the detent grub screw. Is it in focus? Yes, I think it is. I just wanted to say, I think that is a really good example of just poor Harrison design, in detail design. I mean, it wouldn't have taken very much to just have used a shorter grub screw and then had another one on top of it to lock it in place, or even just to have designed some kind of a locking device into that. You probably couldn't have used a jam nut because of where that shoe is, although maybe, possibly, but you know, they could have done something at least. Even if they'd pinned it in place or staked it in place, it would have been better than nothing. Right, we'll move on. Okay people, I'm going to call it at this point, as I've just said there. I don't really want to carry on and start on the spindle cluster or the spindle shaft. I think I'll leave that for another time. The video's already going to be a little bit too long, I think, or maybe just long enough, we'll see. I'm going to edit all together now for you, so you'll be able to see what I've been up to. Sorry about the shaky camera and some of the jumpiness in this video, but as I say, I've tried to film it on the hoof. I've tried to show you exactly what I'm doing on the lathe, in the gearbox, on the bench, just the thought processes and the general kind of flow of the work as I've been trying to dismantle this gearbox, and you know, even the mistakes as well that I've made as I've gone about it. So thank you very much for watching and supporting me. I appreciate that there are much bigger, much more interesting channels out there, but I really do appreciate you stopping by and spending some time with me in the workshop. And if you're watching this and you're not subscribed to me, then please do consider subscribing. And if you are subscribed, don't forget to click the notification bell, because then you'll get to know when I put out a new film. Alright, well, all it remains for me to say now is, again, thanks very much for watching, and we'll see you again very soon when we'll be getting this out. See you soon.